All right, here is our review. And again, as with all of these videos, your best bet, the best thing for you educationally, the best way for you to get ready for this test is to try the problem first, look in your notes, give it an honest attempt, and then check the solution. Don't just copy down the solution. That's not going to help you learn anything. All right, so the first one, summarize in your own words Newton's 3 laws of motion. Now this should be in your notes. You should have words for each of them. Okay, so Newton's first law of motion is that mass resists changes in motion. The first law tells us about mass. Mass is the same thing as inertia, and if the net force is 0, the acceleration is 0, we have constant velocity. Those are all things that the first law tells us. Mass is stubborn and resists changes in motion. Mass is the same thing as inertia, because inertia is the property of an object that says it resists changes in motion. And it says that if the net force is 0, acceleration is 0, and we have constant velocity. Newton's words for the first law were that an object in motion will remain in motion unless acted on by an outside force. That's all of the things that that means. The second law tells me that forces cause acceleration. That's the second law. And if I want to calculate the acceleration of the object, it's going to be the net force, or the total force acting on the object, divided by its mass. And the third law, for every action there's an equal and opposite reaction, tells me that forces occur in pairs between two objects. And each force in the pair must be equal and opposite. We played around a lot with that too. So, those are Newton's 3 laws. Question 2, we have a hockey puck moving to the north. We want to draw a free body diagram for each of the situations. So in order to keep the hockey puck moving, it's already moving to the north. Well, it's going to have the normal force and the weight acting on it. But if I want it to keep moving, I don't need an additional force. I don't need any extra force. No net force is needed to keep an object moving. It's just going to move, let's say, to the right and continue moving to the right. Now, if I want to slow the hockey puck down, we still have the normal force from the ground. We still have the weight down. But if it's slowing down, I need a backward force of friction. Right? So for this situation, the first law tells me that it will keep moving forward because that's what it wants to do. The second law says if I want to slow it down, I need a backwards force that's going to cause it to keep moving forward and slow down. I need a backwards force for that. If I want to speed the hockey puck up, normal force, gravity, but I need a force to make it go forward. I need a net force in the forward direction, in the direction of motion, to speed it up. A net force in the direction of motion is needed to speed the puck up. And then don't worry about this circle thing. We haven't talked about circles yet, so let's not worry about that one right now. But we'll get to it soon. There'll be a unit where we do need to talk about that. Now, how are mass, force, and acceleration related? Draw 2 graphs. Well, the equation that I have that relates them is net force equals mass times acceleration. So one of my graphs can be the force of the object versus the acceleration. The slope of that graph is going to be the mass. The other graph, we can do acceleration versus force. That we see a weird kind of hyperbolic graph. The slope of that is 1. I don't really have a slope. The slope of that is 1 over the mass. Number 4, what's the weight of an object? This is an important sequence. I really want you guys to focus on number 4. What's the weight of an object? Well, weight is the force of gravity, which means it's the earth pulling down on an object and weight is equal to mass times gravity, or Fg is equal to mass times gravity. That's all the stuff that weight is. Anytime we have an object on or around the Earth, it's going to have weight acting on it, and that's how we're going to calculate it. What units can be used to measure weight? Well, definitely newtons, but sometimes pounds. But the one that we use in science is newtons. That's the SI unit. And we need to remember that weight is a force. It is not mass. You can't use kilograms to describe weight. How can you change the weight of an object? To change the weight of an object, you can change gravity, which means like going to the moon or another planet, or you can add or remove matter from the object. You can literally take away mass for that. And then to calculate the weight of an object, weight is equal to the force of gravity is equal to the mass of the object times the acceleration due to gravity. And this is a mistake that I've been seeing you make. What you've been doing, in order to find the weight, you've just been saying that it's 10. Weight's not equal to gravity. Weight's equal to the force of gravity. And in order to find that, you have to take the mass and multiply it by 10 meters per second squared. All right, number 5. So we have this boy of mass 100 kilograms and a girl of mass 75 kilograms, and they stand next to each other. He pushes the girl, and he accelerates backwards at 1.5 meters per second squared. Why does he move backwards? This is a third law question. The girl pushes back on him with equal and opposite force. That force makes him accelerate backwards. Calculate the acceleration of the girl. Well, I know those forces are equal. So the mass of the boy times the acceleration of the boy is equal to the mass of the girl times the acceleration of the girl. So we have 100 kilograms mass of the boy times 1.5 meters per second squared acceleration of the boy equals mass of the girl 75 times her acceleration. So 150 is equal to 75 times the acceleration. Divide both sides by 75. And her acceleration comes out to be 2 meters per second squared. Now, after the boy stops pushing, the girl will be moving, and she's on ice. We're saying it's frictionless, so she will keep moving with constant speed, with constant velocity, because there's no friction. Her net force is 0. Now, in real life, there's a tiny bit of friction, so she will eventually slow down. But in this example, it's frictionless, so we're going to say that she keeps going with a constant speed. All right, number 6, we got this rocket. So in a free body diagram of the rocket, we have the rocket force up, so we'll call that thrust. I'm going to ask about the thrust later. And then we have the weight of the rocket down. Those are the only two forces acting on this rocket. So if I want the net force on this rocket, what I'm going to have to do is add my forces. Well, the thrust is positive, so we're going to add the force of thrust. We're going to subtract the force of gravity. Well, I got numbers for all that. Thrust we know is 3750. And the weight, gravity, the force of gravity is the mass of the object, 250 kilograms, times 10 meters per second squared. So it's 3750 force minus 2500 weight, and that gives me 1250 newtons. That's the net force acting on the rocket. Once you have the net force, to find the acceleration, you do the net force divided by the mass, so that's 1250 newtons, divided by 250 kilograms. That gives you an acceleration of 5 meters per second squared. D is a new kind of problem, and this is something I really want you to do and be familiar with doing. What force must the rocket engines exert to accelerate the rocket at 2.5 meters per second squared? Well, the net force on the rocket is still the force of thrust minus the force of gravity. And I can also find the net force on the rocket by doing mass times acceleration. If we look at the information that we have, I don't have the net force, and I don't have the force of thrust, so I can't use the equation on the left. But if we look at the equation on the right, I've got the mass, I've got the acceleration. That's going to help me find the net force. So we're going to use that side first. The net force is going to be the mass of the rocket, 250 kilograms times 2.5 meters per second squared. That net force comes out to be 625 newtons. Now I know the net force. So I'm going to take that, I'm going to plug it back into the other equation. 625 newtons equals the thrust force, which we don't know, minus the weight, which we do know is 2,500. So now we can find the thrust force. We're going to add 2,500 to both sides. And so that thrust force comes out to be 3,125 newtons. You need to be able to do problems like this. Part E, what force must the rocket engines exert to cause the rocket to climb at a constant velocity? If we have a constant velocity, that tells me the acceleration is 0 and that the net force is 0. I also know that the net force is going to be the upward force of thrust minus the weight of the rocket. So 0 is equal to the thrust force minus the weight, which is 2,500 newtons. So we'll add 2,500 newtons to both sides. And that thrust force comes out to be 2,500 newtons. All right, number 7, we have this free body diagram for the object. The first thing I do want to know is the mass of the object. Well, I can see that the downward force on it's 50 newtons. That's going to be the weight. So I want to calculate the weight, but I know weight is mg. So 50, the weight that I know, is equal to the mass, which I don't know, times g, which is 10. So we'll divide both sides by 10. And the mass of this object is 5 kilograms. Now I have the mass. What's the normal force acting on the object? Well, I know in the y direction, that's where the normal force is. I've got the normal force minus the weight of 50. And if this object moves to the right, it only moves to the right. The net force in the y direction is 0 because it's not accelerating up and down. It's just going to move to the right. It's not going to move up or down. So the net force in the y direction has to be 0. So 0 is the normal force minus 50, and normal force comes out to be 50 newtons. How large must the tension force Ft be in order to have a constant velocity? So if we look at that, constant velocity always means my acceleration is 0, always means that the net force acting on the object is 0. So what we need to do is do the net force in the x direction. We're just going to look at those horizontal forces. I know that in the x direction I have the Ft forward minus the backward force of 10 newtons. And since the net force is 0 this time, 0 is equal to Ft minus 10. So that makes 10 equal to that tension force. Part D, how large must Ft be to accelerate at 4 meters per second squared? One way of finding my net force is by taking the Ft minus 10. The other way I can find the net force is by doing mass times acceleration. Well, my mass is 5 newtons. The acceleration is 4 meters per second squared. So that net force is going to come out to be 20 newtons. So my net force, 20 newtons, is equal to the tension minus 10. Add 10 to both sides. And Ft comes out to be 30 newtons. Same situation. We have something else going on. Now it's telling me that the Ft is 40 newtons. So net force is equal to tension minus 10. As always, that's still there. But this time we know Ft. So from this equation we see net force is 40 minus 10. I can get my net force to be 30 newtons. If I want the acceleration, it's going to be the mass times the acceleration. So 30 is 5, the mass, times the acceleration. Divide both sides by 5. And the acceleration comes out to be 6 meters per second squared. All right, and then last one, if Ft is 0 newtons, what's the acceleration? Again, based on that picture, my net force is the tension minus 10 newtons. But if Ft is 0, then my net force is 0 minus 10, or my net force is negative 10 newtons. Now that I know my net force, the acceleration is the net force divided by the mass, negative 10 newtons divided by 5 kilograms, and the acceleration comes out to be negative 2 meters per second squared, which means that the acceleration of the object is in the backwards direction.